using our trig, we're going to revisit our special right triangles. So if you remember, we have our two triangles. We have our 30, 60, 90 and our 45, 45, 90. If you remember, these ones were special because their side lengths always fit a pattern. So what we're going to do is we're going to go ahead and use that pattern to give side lengths to our triangles, and then we're going to look at our sine, cosine, and tangent of these angles. Okay? So we're going to start with our 30, 60, 90. If you remember, across from the 30 was our short side. We called it x, or in this case, I'm just going to say it's 1. Then we took that side. Across from the 60 was our root 3, so this would become 1 root 3. Then our hypotenuse was always double the short side, so it's 2. So again, if you don't remember this, go back and check out our special right triangles video. Now that we have our triangle with our side lengths, I want to know the sine of 60 degrees. We could type this into a calculator, and that value would always be the same, no matter what. Sine of 60, sine of 60, sine of 60 is always this value. And this value is based off of this triangle. So if we remember, sine is opposite over hypotenuse, so the sine of 60 is root 3 over 2. Now your calculator might not tell you exactly root 3 over 2. It's going to give you a decimal, and that decimal is the expression for root 3 over 2. Okay? That's all I'm looking for here. What about the cosine of 60? So the cosine of 60, that's going to be adjacent over hypotenuse. So that's going to be 1 over 2. That's it. 1 over 2. You plug that into a calculator and it's going to give you 0.5. All right, tangent of 60. Tangent of 60, that's going to be opposite over adjacent. So that's root 3 over 1, which is root 3. Boom. These are important values. You're going to see these repeated a lot in math. The more familiar we are with them, the easier it's going to be to use them later on. Okay, sine, cosine, and tangent of 60. Well, now we can look at the sine of 30. Now my angle's changing, so now I'm looking up here, so my opposite side becomes the 1. So the sine of 30 is 1/2. Notice the sine of 30 is equal to the cosine of 60 because my adjacent and opposite sides have switched places. So you could probably try to guess what would be the cosine of 30. Well, if these two switched, I think these two are going to switch. Let's take a look. At 30, adjacent is now the root 3, so we get root 3 over 2. Boom. Nice, right? Tangent of 30 is going to require just a little bit more work. The reason why tangent of 30 is opposite over adjacent, we're going to get 1 over root 3. We're going to rationalize that, so we get root 3 over 3. So the tangent of 30 is root 3 over 3. Sine, cosine, and tangent of 60, sine, cosine, tangent of 30. Next year in Math 3, I'm going to make sure you guys have this memorized. So again, the more familiar you are now, the easier it's going to be later to use them. Okay, we got one more triangle left. We have our 45, 45, 90. This one, if you remember, the side lengths here are the same. So we'll say 1, 1, and root 2. So these two sides were the same, and then we multiplied the hypotenuse by the square root of 2. This is a nice triangle because 45 and 45 are the same angle. My opposite and adjacent side are always going to be equal to each other. So if I try to find the sine of 45, the sine of 45 is going to be opposite over opposite over hypotenuse. Sine is opposite over hypotenuse. I get 1 over root 2. And when I rationalize that, I'm going to get root 2 over 2. Well, what's going to happen when I do the cosine of 45? cosine of 45, doesn't matter which 45 I use, because adjacent and opposite are the same, I'm going to get 1 over root 2. Again, got to rationalize that. So I get root 2 over 2 for cosine of 45 as well. So here, cosine and sine are equal. Here, my cosine and sine switched places because the 30 and 60 switched my opposite and adjacent side. Last one, tangent of 45. We're looking at opposite over adjacent. No matter how big or how small that triangle is, if it's a 45, 45, 90, that means it's isosceles, which means the opposite and adjacent are always equal. So tangent of 45 is always 1. Okay, use that. Hopefully it makes sense. If you got questions, let me know.